Well, thank you. Welcome. Good afternoon. My name is Greg Gloria from the Nerdstalker Media Network, and on behalf of the Cal Poly Graduate Education Program, we thank you for attending the Systems Integration Engineering Professional Certificate eInfo session. And anyway, let's talk about the agenda. Let's talk about and the seminar here. We hope to give you a kind of a glimpse of Systems Integration Engineering Graduate Certificate Program at Cal Poly San Luis Obispo. And today's guests, let's introduce them. We have Kurt Colvin, professor from the College of Engineering and the director of the Systems Integration Engineering Program at Cal Poly. And he'll discuss a little bit about the program. Then we have Scott Sommer, a graduate of the Systems Integration Engineering Program and a practitioner and a person in laboratory automation. So he'll bring you an interesting perspective on the program and how it's helping him. And then after that, we have Roger Burton, a former C-level executive working at as a systems change consultant and change catalyst with many of the world's largest corporations. And he'll talk a little bit about how maybe this kind of program is geared not only to specific items in systems engineering as you know it, but as a way of maybe thinking as a systems change analyst. So let's get started. I'm going to introduce Kurt Colvin here, and why don't you take it away, Kurt?
Okay, thanks, Greg, and I will share my screen here, and I just have a few slides. And what I basically want to do in this short session is give you an introduction to the topic, the technical concepts of the program, and then a little bit about how we implement it and the logistics of the program. So the first concept that I think is really important to understand is engineers often apply the system lifecycle to engineering systems. And so if you think about there on the left, somebody has a need, that need becomes a set of requirements. Engineers go to work designing a possible solution. They build those components or those pieces. They put them together and they test them. If everything works out right, they move into the operation phase of the life cycle, and probably sometime in the future, the system becomes obsolete or it's upgraded or it's no longer needed, so then it moves into a disposal phase. And so very abstractly, we talk about systems in that kind of phase-oriented life cycle. So if you start with that as kind of the baseline, I'm going to give you a couple of definitions here. And the first thing I'm going to talk about is systems. And so you might think about systems something like my favorite subject, airplanes. And so you can think about the airplane itself being a system, but often we want to talk about a system boundary that's a little bit bigger than that. So we also put things like weapons on board, or we put cargo that we're carrying in it. But there's also things like support personnel, and there's the Department of Defense is the customer that uses it within a whole constellation of different airframes and things like that. So we can, kind of shrink and expand the definition of systems in many different ways. But that would just be one example of a system. You could look at consumer electronics as another system. So there's lots of complex components in each of those. But then we have to think about, the supply chain, and we purchase parts of those, and we have to support them when they break. And we have all the personnel in the stores that sell the systems. So again, you can shrink or expand the boundary depending on the context you're talking within. Medical systems, or our healthcare systems, would be another definition of a system that we could address and we could develop new components or new systems for. And finally, maybe an automobile manufacturer would be another system that has to be designed, and it moves through those life cycle phases. So when you kind of abstract what a definition of systems are in the end, it's just simply a set of interacting entities that have a function or purpose. And I should probably qualify that a little bit to be, we're talking about man-made or engineered systems in the context of this program. The second word I might try to define is integration. And so the way engineers typically address big problems like this is they take the reductionists, or they decompose the complex system into simpler components, and then different teams of people or individuals go to work designing and building those components. And then at some point, we start putting the components back together into subsystems and integrating those into larger systems and integrating those maybe into systems of systems. And so if you think about going from the components to the operating whole, we just say integration is just to bring together into a whole. And finally, the last term I would just have a stab at would be engineering. And to me, engineering is just solving problems using science and technology. And by science, I'm talking about the natural sciences, but mostly I'm talking about the scientific method of observing something or proposing a possible solution and then testing to see if that solution will actually solve the problem. So it's the scientific method combined with lots of technology, machines and processes and methods and tools, all those things together to try to solve problems using science and technology. So then if you take those three definitions and I kind of spin it into just a definition of systems integration engineering, it would be a process that evolves and verifies an integrated lifecycle balance set of system solutions that satisfy customer needs on time and within budget. So basically developing the right system within the constraints of time and money. Just a couple of more definitions I'll just quickly pass over. So SIE is really trying to develop the right technical system, but when you bring people into the mix of it all, not just the technical components, but the people too, then we also try to address a couple other things in this program. And one is systems thinking, and I would just say that's a way of looking at the world while considering many perspectives, including the non-technical part of engineering or the soft systems of people. And finally, systems theory is really just the study of general systems, trying to elucidate principles that we can apply to all systems. So that's a bit of the people side in addition to the technical side that we're trying to address in this program. So those are some definitions for you. Now I'm just going to take a couple of minutes and give you kind of the overview of the logistics and how the program is rolled out. So there are really 4 courses that are part of this certificate program. It starts with 509 in the fall, and then we have 3 follow-on courses. And let me explain a little bit about that first one. Is just a 2-day, 2 8-hour days, and it's worth 1 unit. And then the other 3 courses are each a full quarter long. We have quarters here at Cal Poly, 10-week quarters, and each of those are 10 weeks long. So that kind of makes up a 9.5-month program. And altogether there, that is 13 graduate units, and those are approved technical graduate units that could be applied to another program. And we have several master's programs here at Cal Poly that would take these as graduate work, and most engineering programs would accept these units, but of course, depending on where you go, you'd have to apply and see if they would accept those. The first class is actually on-site here in San Luis Obispo, and it has really been a chance for us to meet each other and get to know each other and really kind of start to develop a relationship, because after that 2-day on-site, the rest of the courses are all online. We have synchronous class meetings, so we have 2 class meetings a week. They're Monday and Wednesday afternoon from 4 to 6 p.m. on the West Coast. Those are really a chance for us to get together and collaborate and discuss online, but all the materials are electronic and they're stored on our learning management system. So all the content is online, available asynchronously anytime, but we do have synchronous meetings where we sit together about 4 hours a week. The cost of the program is $500 a unit, so 13 units. The total cost of the program is $6,500. So that's the logistics, and I'm happy to answer any questions there are, but I think I'll stop right there. And maybe I will just leave you, I guess I would say that the timing for it is September 11th and 12th is the on-site portion, and then fall, winter, and spring terms starting this fall will be the timing of it all. And I guess I would just leave you with a metaphor for systems integration engineering, where the development of systems is kind of like an orchestra, and where each person kind of has their expertise and their tools. So you might think about the mechanical engineers and the electrical engineers and the purchasing agents and the contractors and the HR department. All of those people have their specific skills and contributions to the system as a whole, but it's the systems integration specialist that tries to integrate all those components so that they work together towards successful systems. So thanks very much for the time. There's the website and my email address. And with that, Greg, I think I will pass it back to you and let you take over again.
Thanks. Thank you, Kurt. I appreciate that. So we had a couple people join us after I did the intro there, but if you want to ask questions, we're going to have a Q&A session right after this, and if you're viewing it on the event window, you'll see a Q&A button in your upper right-hand corner of your window. Press that. I already have some questions already, and we'll answer that at the end. But go ahead and press that, and you see a new window pop up with a grid box. In the side of the grid box is a Q&A button, and then another window will pop up, or a sidebar will pop up, so you can actually type in your questions. And type them in any time. I'll see it on my moderator screen here, and I already have one question from Perry, so I got your question, Perry, and we'll answer that right at the end. So anyway, next, I'd like to, invite Scott Sommer, who's has experience as an R&D engineer in the medical device industry, and is now in the field of laboratory robotics, basically precision fluid handling. And he's also a graduate of the SIE program, and he's going to talk about how, this is how the program kind of worked for him and how it's helped his career. So go ahead, take it away, Scott.
Thanks, Greg. Yeah, I am a recent graduate of the program, and so I'll start right off by saying that I was really happy with it. It worked out well for me. In fact, so much so that when Kurt asked if I'd be willing to help provide information that might help others to get involved in this, I was more than willing to do so. Today I'll try to give a picture of why I enrolled in the program, how the program went for me, where I think I'm already seeing benefits in my job. So to address that, why did I enroll? Well, as an engineer in the field of laboratory automation, I'm seeing increasing complexity in the projects and products that I work on. It seems that today's systems, you have to share more data, support more access and connection in varied ways than ever before. The instrumentation has to perform more precisely than ever before. Frankly, I felt like I needed a little help catching up to these challenges, and I thought, well, what would be better than a deeper understanding of systems engineering? I was familiar with that term as being associated with aerospace primarily, and when you think about it, systems don't get much more complex or high-end than if you're putting somebody in space or flying 300 people around the world. So I felt like there was probably something that I could learn from that. How did it go for me? Well, I'm busy, and I had some concerns about how do I work this in. Between commuting to work and time at work, I easily spend 50 hours a week, sometimes as much as 60, involved in my work life. And I wasn't sure how I would squeeze all this in. Well, when I saw that it was offered online by Cal Poly, that of course was appealing. As a graduate of Cal Poly, I understand the school's mission and reputation, and I was excited to learn about an educational opportunity that I could participate in. It was relevant to my career, and I could do so from well outside the Cal Poly area. Initially, as I said, I had a few reservations about how well an online program would work, but I also recognized that in the world and as my professional challenges are changing more quickly all the time, and I thought, what better way to prepare for increasing technical challenges than a class based on the technology of today? So that intrigued me, and I went for it. Kurt spoke to the orientation portion of the program that you do at Cal Poly, and that's really key. I'll expand on that a little bit because the 2 days on site really lay a foundation for the rest of the program. When you're in an online environment, if you didn't already know these people, if you didn't feel some connection to them, I can see how that might be a little bit challenging. But because of this 2 days that we spent together, getting to know each other, working through the tools that are used and the technology in the program, you end that weekend feeling like, hey, this is going to be great. It's all going to work out. And then I'll tell you, every Monday and Wednesday when I signed on to the class, it just felt different than had I not met those people up front. You know, I kind of felt like I was seeing familiar faces. We already had an understanding of what each other was all about. And for all intents and purposes, the rest of the 3-quarter program flowed almost as easily as if I was sitting in the same class with people. So if anybody had any concerns about what is it like to take an online class, let me put that to rest right away. The orientation breeds that familiarity, it lays a foundation, and it all just works after that. Kurt also spoke to the quarter system a little bit. If your educational background is from a semester-based system, quarters are pretty cool. Things happen quickly. About the time you hit your stride and feel like you know, I've got this, now we're really moving in this class, you can already see light at the end of the tunnel. So all of that moves really quickly. The other thing that's nice, he mentioned about how everything you need is accessible through the web page. Having everything in one place, everything that you need in order to participate in the class, organized on one page, really helps out. And another thing that it did for me, it gives you an element of flexibility that I didn't appreciate before taking the class, but I do now. You know, life goes on, and I needed some vacation time with my family. So right in the middle of one of the quarters, my family and I went to Hawaii. I was able to check in at the class. I was able to, you know, keep up with the homework, understand what was really important. If there were a couple things that I felt like, you know, that just doesn't seem like that big a deal, I'll let that one go. That access from anywhere in the world really helped with that. Another element of the class is we do a fair amount of reading. There's generally a book involved, but it is not necessarily a textbook. You know, don't feel like this is going to be a repeat of thermo or dynamics where you're going to spend all day going through a textbook. There's a pretty clean way of integrating a valuable book that gives you skills and exposure to things that are really going to help in your career. One of the books that we spent a lot of time with was a book called the Toyota Production System. Toyota is known the world over as just a world-class manufacturer. We spent a lot of time going through elements of what they do, and you know, that's something that I've gone back to time and time again. I'll speak to that a little bit later. But between the website, the reading, it flows basically like any class you were used to, and it just really tends to work. Quickly, some of the detail that we hit in the various quarters. We talked about an introduction to systems engineering. What are the characteristics of a system engineer? We spent a fair amount of time talking about requirements of a project, of a product. How do you develop them? I know one of my challenges in projects has always been, how do you get a good set of requirements? And there are tools that can be used. So we spent some valuable time talking about that. We spent valuable time talking about projects themselves. How do they flow? What are some of the challenges that are common across all the different projects? What are some of the pitfalls that people run into, and how do you deal with those? We talked about system integration, the actual act of starting to bring all these elements together, and What are the different methodologies or schools of thought on how you start to bring up a system with a lot of complexity and not get bogged down in minutia or problems that really aren't a problem, maybe aren't part of the big picture. And we moved on to verification and validation. V&V is a big part of what I do, and seeing how other people in other industries approach that was helpful. And it was interesting how things go full circle. We even talked about how do you lay groundwork for a successful V&V back in the requirements stage. So that's the program as it went for me. To speak to the specific benefits I've seen, I want to go back and quickly talk about the Toyota production system again. They have a concept called Genshi Genbutsu. And Genshi Genbutsu roughly translates to go to the source. The reason that's important is in my job as a manager of some people, projects, I always have to walk a fine line between needing to know details in depth versus delegate and expect people to handle it. And I struggle with that. I really used to struggle with that because, I'd always been trained that a good manager delegates. As we covered this concept in the Toyota production system, you learn that within Toyota, people go to where the problem is. They go there and they figure out what's going on, why is this happening? And while it may seem like a little thing, the understanding that one of the world-class manufacturers actually forces people to get personally involved, that helped me tip that balance between when to delegate and when to go do it. I now feel a lot more empowered and comfortable dropping what I'm doing, going down, getting involved with the people on my team and saying, what's going on? Let's talk about this. When I walk away from here, I want to understand specifically what's going on. Without this program, I'd still be back in this quagmire of, well, I need to delegate and they'll figure it out. One other thing, just as a closing thing, as we talked about projects, task estimating is something that we all do. My experience has been task estimating is hard, and almost inevitably, as soon as I estimate something, I'm wrong. I'm behind. We're always behind. Well, we talked about that during one of the quarters when we focused on projects and how they flow. We talked about the exercise of estimating tasks and what are some of the say rookie mistakes that people might make, and it actually has an element of probability to it because people's knee-jerk reaction is to give an estimate that's based on roughly a 50% chance of being right. And when you think about how tasks tend to occur in a serial nature, well, as soon as you're wrong on one of them, it sets everything else off. So what I took away from that was, hey, I need to estimate tasks differently. I need to give an estimate that's based on a much higher probability of being right. And, I'm a little more conservative now. Things look like they're not going to be done as quickly, but in reality, I think we get things done more quickly because we're right. We don't give a rosy schedule that we fail to meet. We give a more conservative schedule that we do meet. So I guess to sum it all up, what I've taken away from the program really exceeded my expectations. I feel better equipped to deal with the growing complexity, and I enjoyed myself on the path to getting to this place of enlightenment.
Well, it's great. Well, thanks, Scott. Appreciate your comments there, and thanks for sharing a lot of your stories of how a professional environment kind of translated into this program, how the program translated back into the professional environment. We have a couple people that just joined us, so I just wanted to kind of go over. Right now, we're kind of going through the agenda where Kurt Colvin already had presented on the outline of the program. we just heard from Scott, who kind of was a attendee of the program and a recent graduate of the program, and then we're going to go next into Roger, who's going to talk about from a executive's point of view, a change agent's point of view, how to do this. But before we go into that, if you guys want to ask questions, we're going to have a QA section right after Roger's portion, and if you're viewing this on the event window, you could click the Q&A box which in your upper right-hand corner of that window. It'll show another window with a grid of boxes. Clicking the grid of boxes, have a QA symbol in there. Click on that, and I've already had a couple questions from Perry Johnson. Thank you, Perry, for that. Also, who joined us actually live here is Denny, and I appreciate you coming on, Denny, and I'll release your microphone after we do the presentation if you want to ask any questions live. But yeah, I already have some questions already here. So anyway, we're going to go ahead to Roger. Let me introduce Roger Burton. He's a systems change consultant and change catalyst working with corporations like DP, BMW, GlaxoSmithKline, GSK, as they know now, and biopharmaceutical company AstraZeneca. So Roger will discuss why systems integration engineering is not just a methodology, but in a true sense, but a way of thinking. So go ahead, take it away, Roger.
Thank you, Greg. Basically, I just want to try to build a little bit on what some of the definitions that Kurt was offering, and hopefully talk about what's the point of view that Scott was expressing, but from a slightly different perspective. So, for several decades, I've worked in great part in highly technical organizations. So organizations with technical expertise, often engaged in complex tasks with high stakes, both financial and in terms of safety. And one of the things that I learned from speaking with people in those organizations for that period of time, I would essentially ask people, well, how long did you invest? How much time did you spend, or what was the nature of your investment to prepare yourself technically for the set of activities that you imagined would make up your career? And usually that's something like a decade or so for people to have become prepared technically. And then I would begin to ask, how much of your time do you spend directly applying the technical skills and distinctions that you acquired in that period of time? And what's typically the case is that as people advance in an organization, they begin to lead teams, they manage projects, they begin to have management and leadership roles that begin to take up more time, to where it really ends up, like 10 or 20% of their time is the direct technical application, and then there's 70 or 80% of time that's something else. Well, what is that something else, and how do we relate to it? And you could say, oh, it's leadership, it's communications, it's these things. But in the definitions that Kurt offered, he distinguished between systems engineering, systems thinking, and systems theory. And if you think about systems engineering as a body of very specific distinctions within a particular domain of design and implementation, and systems theory as the generalized set of theories, principles, whether it's archetypes, that help you describe systems. In between there someplace is systems thinking, which is essentially a way of taking those distinctions and seeing the world through them, such that when problems are arising in the non-technical systems, the complex systems of human beings, that you actually have a way of navigating it that you've learned from your technical distinctions, from your systems theory, so that as a leader or a manager, that you become a systems thinker. And then instead of dealing with one-off problems, one after another, kind of endlessly putting out fires, as Scott was talking, you go to the source. You begin to look at the systemic structure or the systems that are sort of perfectly producing this set of phenomena using your systems engineering distinctions, using systems theory through systems thinking, which is a way of essentially looking at the world and then designing in non-technical or complex systems. So there's something about this being a mid-career offering that might be very appropriate for people as they begin to manage that dilemma. The dilemma of how do I take my technical understanding and usefully apply it to the set of dilemmas and problems that I have now, in addition to whatever literal product or technical specification I'm creating, whatever system I'm engineering. I also have all the systems in which that is occurring and upon which that is dependent. So I think I don't really need to, I hope there's some questions, and you know, I don't really need to say, I don't think really much more. I'm really more interested in interacting about questions than anything else. Unless there's anything else, Kurt or Scott, you think I ought to include? All right, good.
Yeah, sounds good. I appreciate it, Roger. I think coming from your perspective and seeing it from a top-down level as well as in being a consultant is really kind of important in the way you're thinking about systems, not only, as Kurt said, you know, mechanized systems, but human systems as well. So that was good. So I think we're ready to do the Q&A. I'll release Denny's microphone, but also, again, if you want to ask a question of the panel here, just hit the Q&A button, ask your questions. I already have 2 questions queued up, and you know, and we'll give you some Kurt will give you some information how to apply for the program and how to do that at the end of the Q&A session. But anyway, let's go to the questions. It's from Perry Johnson. He said that I'm not trying to apply to the program yet, but through the link I saw on the SIE website, there's a firm. Is there a firm cutoff date or for applications, Kurt?
There's really not. Kind of logistically and common sense-wise, we need about a week at the end to put it all together. So I would say early September would probably be the latest you could apply, and we make it work for the year.
Okay. And then secondly, another question from Perry. Thank you, Perry. Are the biweekly synchronous meetings required attendance from 4 to 6 p.m. or, you know, work may get in the way, so he's a little bit concerned about that, so you might want to discuss that as well, and maybe Scott could give a perspective how he's also made it work.
I think that would probably be the best option, is to go to Scott and say, Scott, are those sessions required?
Yes and no is the easy answer. I mean, to really get anything out of it, you need to be there the bulk of the time. But I will say that there's tremendous flexibility in the program. The sessions are all recorded, and again, they're available on the web page that represents the class for that particular week, as I said. So if you do miss one, you can always go look at the class session. The additional material you need is right there on that same web page. So to do it justice and to get the benefit, you need to be able to be there the majority of the time, but there is inherent flexibility built into how it works. And if you have a crisis at work, which absolutely happened to me over the course of the year, occasionally you can't make it, you can certainly recover from that. The course is set up to deal with that.
Well, you know, graduate programs are kind of a little bit different, right? I mean, you know, and this is really, even though it's a certificate program, right, Kurt, it's a graduate level certificate program, right?
It is correct, and I think that probably a distinction that's important to make is, you know, the curriculum has been through the approval process with the Academic Senate at Cal Poly, so these are all approved technical engineering courses, so it's nothing about that these are not engineering courses.
And these are, Kurt, you know, correct me if I'm wrong, I believe these are accredited courses, so they go towards a graduate degree, right?
They do, and you got to be a little bit careful about the word accredited, because usually that means ABET accreditation, which is undergraduate only. Right. But you know, we have 5 master's programs here at Cal Poly: mechanical engineering and industrial engineering and biomedical engineering, and a few others that have already said, hey, these are right in line with the technical electives in our master's degree, and so we would accept these as units towards a master's degree.
Okay. You know, let me ask a question. You know, I don't have any other queued up questions right now, but maybe Roger, you might want to talk about, you talked a little bit about kind of the systems way of thinking, and since you're kind of a change agent, you're kind of brought in to help. I think you've done some cross-cultural changes in companies and stuff like that, or managed that to them. I mean, how has the systems kind of thinking has helped you kind of change your approach towards even doing that type of job?
Yeah, there's a few things. Well, first, I've worked in about 50 different countries, so I've kind of all around the world in many, many different settings. And it's funny about when you think about systems or the definition of a problem, you can kind of, in a simple way, you can think about simple systems, which are typically mechanical in some way, complicated systems, or complex systems. And the main distinction between complicated and complex systems has to do with kind of unpredictability and emergence. So human systems are typically complex systems. And one of the things that can happen in a technical organization is a confusion can arise between applying sort of the distinctions or way of solving a problem that you would use in a simple system to a complex system. And if you get those confused, it can be pretty bad. So let's say you've got a planned turnaround on your asset. And during that planned turnaround, you're going to shut down many of the main components of your asset, and you're going to restart them. It's one of the most dangerous things you can do. You definitely want technical rigor, management, and control process for all of that. And if you treated that like it was a human system or a complex system, it could go horribly, horribly wrong, and you really wouldn't want to do that. On the other hand, during that planned turnaround, the population of your site has probably tripled. And so that's a human system. And if you were to try to manage that like it was a technical system, it can equally go wrong. Also, just in terms of an example of mindset when you begin to look at the world as a system. And there are different ways to do that. In a complex system, you might understand a system as being defined by shared properties as opposed to a boundary. But there's some phenomena occurring, and you encounter that phenomena and you call it a problem. And then systems engineering, you solve for that. Well, when you're thinking as a systems thinker, one of the things that you might think is not simply how do we solve the problem, but you would stop and you would ask yourself, how is the current system perfectly producing that phenomena I'm calling a problem? So you actually look and see what is the nature of the system producing the phenomena you problematized before you just begin applying a set of assumptions and solutions to the problem. And it's a very simple shift in mindset that you begin to apply across the entire domain of systems, whether technical or complex. I don't know if that's useful or not.
No, it's good. No, I appreciate it. I think it is somewhat abstract if you think about it, but I think I've gone through graduate programs to learn about that as well, and as more you get to think about that way, the more it gets comfortable, actually. So, thank you, Roger. I think we're going to try to close this off. There's no other queued up questions. Again, if you wanted to ask a question, go ahead and either unmute your microphone, Denny, or go ahead and press that Q&A button. But I think, Kurt, we'll probably close on how do people apply for this program?
Right, so if they just go to the SIE website and they look under the Admissions tab, then there's an Interfolio link, and I think there's no cost to it. It's just answer a few questions, submit your proof of undergrad degree and your work experience, and submit, and that gets to my inbox, and then I'm able to review and approve or communicate appropriately. So it's a pretty simple and easy, no-cost process.
Yeah, and one way to get there is grad.calpoly.edu/programs/sie.html. Sorry, it sounds complicated, but it really isn't. And the apply button's right there, and it'll actually get to clear. And actually, if you have any questions, you could also additionally ask questions through that program window as well. So, Anyway, there's no other questions. I don't think there are. I appreciate Perry for a lot of the questions, and thanks for the people who joined us online and making the effort. We appreciate also Roger and Scott to come on here to give their perspective on what systems thinking and how systems program has actually helped someone in a professional environment. So anyway, this is Greg Gloria for the Nerd Stalker Media Network for the Cal Poly Graduate Program. We really appreciate you guys joining us, and yeah, we'll see you soon. All right, thank you.